Well, good morning, AP Chemistry. I wanted to look at the problems. I know I promised was going to go over those from the AP exam from 2014. I probably should have done this a little sooner. I'm trying to allow some of you, most of you, to get these into me. But anyhow, I'm going ahead and go ahead and show you how to work out number one. What I'm going to do is to show you the way I worked it out, and then also throw in the way the scoring guidelines that the official graders use. Okay, in the first one there, I gave you this reaction to start with. It's nothing that was needed, just I like to write reactions down. So A.1 says write a balanced net ionic equation for the reaction. Okay, so you got to look at what was formed, the precipitate that was formed. So you got lead 2 ion plus 2 iodide ions gives you lead 2 iodide. And I like to make sure it's balanced, of course, balanced electronically from the charge standpoint and from the elemental standpoint. I like to show these are aqueous and that's a solid. Essentially, they did the same thing, although they didn't show aqueous and solid in that. Just something I like to do. Why is a reaction best represented by a net ionic equation? You're eliminating the spectator ions. You're showing what's really happening here. You're showing the true reaction, and that's essentially what they asked for. That's what the answer they gave as well. Explain the purpose of drying and weighing the filter paper with the precipitate 3 times. You're always trying to get constant mass. If you just measure it one time, there still could be some water there. So you heat it, you measure it again. If the mass changes, then you do it again, as you saw there. Notice then that it really barely changed to the 3rd time. Say, yeah, I'm there. So you're trying to get constant mass is what that's after. In letter C, and you may recall this from the previous time I gave you parts of this problem, in the filtrate solution is potassium concentration greater than, less than, or equal to nitrate. Well, I wrote down it's got to be less than nitrate because we're told that lead 2 nitrate was added in excess. So there's more than enough there. Okay, in D, it says calculate the number of moles precipitate that is produced in the experiment. So I said you've got 1.698 grams of the lead 2 iodide and filter paper. Whoops, let me start this over again. Sorry about that. 1.698 grams. This is with, and then the mass of the filter paper was 1.462 grams. Gives us a total of 0.236 grams of the lead 2 iodide. Using the periodic table, I like to go 2 places past the decimal. It's 461.12 grams of lead 2 iodide to 1 mole of lead 2 iodide, and gives you 5.14 times 10 to the negative 4th moles of lead 2 iodide. Now, generally speaking, you go greater than or less than 3 places beyond the decimal. Kick it in the scientific notation. I don't know if they would not give you the point if you'd had a 0.000514. That's just the way I like to do it. All right, calculate the mass percent of iodine in the tablet. Well, what I did is I took the mass per mole of iodine, the mass per mole of the grams of potassium iodide, times the total mass of the potassium iodide. In other words, this is the percent of iodine in potassium iodide, and this is the mass of potassium iodide I have. And what that gives me then is 0.130 grams of iodide, ion, basically. And the total mass of the tablet is 0.425 grams, of course, times 100, and that is 30.6%. Now, what they ended up doing was they said, maybe I can show you here. Okay, they said you get 5.12 times 10 to the 4th moles of lead iodide. 1 mole to 2 moles of iodide gives you how many moles of iodine? And you multiply that by the mass of iodide. You get 0.130 grams. And you take that divided by here, which is what I have done. And you obviously get the same answer. So either way is fine. This is the way my brain thinks, so that's why I went ahead and went that particular direction. Okay, in letter F, it says another trial student dissolves the tablet in 55 milliliters of water instead of 50. Predict whether the experimental mass of iodine greater than, less than, or equal to. Well, the mass is going to be the same. The water is just there. It's just there. It's going to be evaporated out. The excess water is evaporated out. So that would have no bearing whatsoever on the answer. And then finally, G, a student in another lab wants to determine iodide content, not have access to lead 2 nitrate, but has silver nitrate. Will that work as well? And they give you the KSP value for silver iodide. And it says, will the substitution result in a precipitate? Yes, is the answer. Why? You have to justify your answer. Well, the KSP is so low, the solubility is going to be minimal. So therefore, yeah, it's going to precipitate out just fine, so no need to worry about that at all. And then in part 2, the student only has 1 potassium iodide tablet, and the balance can only go to 0.01 gram. Well, can they use silver iodide at 3 significant digits? No. I mean, your mass is going to be less than a gram, and therefore you can only get 2 significant digits out of a two-place balance. So therefore, no. The error is plus or minus 0.01 grams. So that's not to 3 significant digits, only to 2. So hope that helps. That's how you do number 1. I'll make a video a little later. I think I gave it 4 and 5, and then 6 and 7 was today's assignment. So hang in there, keep plugging along. I know this is getting old, but hey, you're down to a couple weeks before the exam. So stick with it. Bye.